three types of carbocations. Okay, they are called primary carbocations, secondary, and tertiary. Now, primary is when you have one R group attached to the carbon that is going to have the positive ion. And then when you have secondary, you have two R groups attached to the carbon. And tertiary is going to be when you have three R groups attached to the carbon that is going to have the positive ion over there. Now, one example, each of them, I give you example. Okay, you see, this is one R group. Okay, so this is going to be the carbon attached to the positive. So this is going to be a primary carbocation. This is the carbon. So you see, this is going to be two R groups, secondary carbocation. This is the carbon. So you have 1, 2, 3. So tertiary carbocation. Okay. Now, what is going to be what you need to know about these R groups? Okay, the R groups, they have ability to push electrons away from themselves. So they are more like electron donors. Okay, they like to push the electron away from themselves. So we say that R as electron donating tendency. And this electron donating tendency, we have a special name for it. Okay, the special name that we use is going to be positive inductive effect. So what is going to be positive inductive effect? Whenever the R group, okay, push the electron, okay, or when the R group gives the electron, okay, donates the electron, they will exert something what we call as positive inductive effect. What is positive inductive effect? Let's have a look at this example over here. Now, when I show in this diagram, you see the R group is the one that will try to push the electron. You see the R push the electron towards the carbon. This one push the electron, push the electron. Do remember, it is pushing the electron. Now, Dylan, if I ask you this question, which one has less charge density? Which one has less charge density? Do you know what is charge density, Dylan?
The one that has less charge?
Yes. Yeah, you can actually answer it in that way. Forget about the density. Which one do you think will have less charge?
The primary.
Not really. Okay, not really. You see here, what is charge density? Okay, charge density is going to be like a measure how much charge is there in one particular volume. Okay, in one particular volume. So that's why it's measured by charge over volume. Or this volume in atom or any kind of molecule, we don't use volume. We can refer it directly to the radius. Okay, so it's going to be charge over radius. But what does it mean? Basically, it's going to be the amount of charge. Now, when they have positive one charge, positive one charge, positive one charge, okay, whenever the R group is giving or pushing the electron towards the positive charge, what do you think will happen to the positive charge, Dylan? Do you think the positive charge will decrease or do you think the positive charge will increase? When they push electron?
Decrease?
Yeah, they are positive. Electrons are negatively charged. Okay, when they are going to be pushed towards positive, okay, the positive will decrease. And of course, if you are pushing a lot of negative over there, then the positive will be much more lower. Okay, so which one has less charge density over here? The answer is tertiary carbocation. Tertiary carbocation has less charge density because of the positive inductive effect from the R groups. Okay, positive inductive effect. Now, you see, if I want to answer this, the answer is going to be tertiary carbocation. Okay, they are energetically more stable. Okay, because the charge is not concentrated in one place, but spread over several atoms. Now, this is going to be an extension to what I was explaining about positive inductive effect. Now, when the electrons comes near you, okay, when they are trying to share the electrons to you, you are going to share your positive charge to the others, okay, to the others. And when that is happening, the charge starts to spread throughout the molecule. The charge starts to go to this molecule, this atom, this atom. So they are going to become much more stable, because now, rather than concentrated in one particular position, you are going to put it everywhere. Okay, and it is going to become much more stable because of that. Now, to explain this, I can explain this using this diagram. Okay, explain using this diagram, which I always like to use, this diagram, this kind of diagram. Okay, imagine that, okay, you are carbocation. Okay, carbocation is something that has lost electron. Just imagine this is a person who just broken up with a girl and is depressed. Okay, he's sad. Okay, so he's sad. Okay, and then there is someone, maybe a friend or something like that, trying to tell, okay, don't be sad. Okay, trying to spread love. Okay, don't be sad, and so on. It's okay. Then maybe he can still share, okay, the feeling and so on. Now imagine the same person, okay, is going to be sad, but now, okay, he has, okay, one friend, another friend, maybe parents. Okay, there are more support system, and he is going to tell the problem, and they are going to share the problem together, and you have more people sharing it. So the sadness will be spread to all these people. It means you, in the end, you are going to become more stable. Okay, you are going to be happy a bit. Okay, but compared to this person, maybe don't share properly, so end up being suicidal. Okay, why? Okay, I don't know. Okay, basically very sad. But if you compare with this guy, it's not going to happen. Okay, it's not going to happen, because, okay, the thing is, the sadness was spread to a lot of people. This is what I want you to remember whenever you remember about positive inductive effect. I want you to remember this diagram when it comes to positive inductive effect. Positive inductive effect is going to be when the R group, okay, is going to push the electron to the carbocation. Okay, the charges, okay, the positive charges are going to become less, and it is going to be more spread out to the other atoms, and this is going to make this person to be more stable. Okay, to be more stable. You can remember it in that way. Okay, anything that can make you remember. Okay, let's explore that. Okay, now the next